So it is really important that you do a quick sketch as to draw out what is actually happening with this question, because once you've drawn it out, you'll be able to see, but you've got to show that the ratio between P to A and P to B is the same as 1 to 2p squared, and this is worth 8 marks. So the first part is 4 marks, the second part is 8 marks. Now when the students actually did this at the time, not many students managed to get down to 1 to 2p squared. It was very, very difficult to come up with this answer for the 8 marks. So if you do manage to get to 1 to 2p squared, you've done really, really well. Now the key facts you'll need to be able to help you to answer this question. You need to know the equation of the tangent, which is y minus y1 equals mx minus x1, where x1 is going to be your x coordinate, 1 over p, and y1 is going to be your y coordinate, 2p. You need to work out how to find the gradient of the tangent, which is going to be m. Now you've been given an equation in terms of x and y in terms of parametric equations. So you're going to have to use the chain rule to work out dy by dx, which is dy by dt times by dt by dx. So you'll need to differentiate both these terms, flip the dx by dt upside down to then work out the value of dy by dx. Then in part B, you'll need to work out the gradient of the normal, which is minus 1 over the gradient of the tangent, because you've been told here you've got a normal. And then once you've got this gradient of the normal, you'll need to use the equation of the tangent again. And in part B, it's really important that you draw a diagram so you understand what is going on, because until you can visualize what you're trying to find, you won't be able to find it if you do not know what you're trying to find. So press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. Okay, great work, guys. Hopefully you've managed to come up with an answer. To start with, we're looking at the equation of the tangent, which is of this form here. I already mentioned earlier y1 was equal to 2p and x1 was equal to 1 over p, but we've got to work out the value of m. So we're first of all going to differentiate this function x. Now x is equal to 1 over t, which is the same as t to the minus 1. So when we differentiate, we times by the power and take 1 from the power. So that is going to be minus t, take 1 from minus 1 gives you minus 2, which is the same as minus 1 over t squared. We're now going to differentiate y, so the differential of 2t is just going to be 2, so dy by dt is equal to 2, and this will give you your first mark for differentiating both these expressions. We now need to substitute these into dy by dx to work out the gradient of the tangent. So dy by dx is dy by dt, which we know is equal to 2, times by dt by dx. Now we know dx by dt, so we have to do the reciprocal. So dt by dx is going to be 1 over minus t squared, which is just going to be the same as minus t squared. So I've got 2 times by minus t squared, which is going to give me minus 2t squared for your second mark. From here, we've got to put the values into the equation of the tangent. But before we do that, you'll notice that these values here are in terms of p, and this equation here is in terms of t. Now, as I said right at the beginning, there is a relationship between this equation here and here. So 1 over t is equal to 1 over p. So you should be able to spot initially if x is equal to 1 over t, at p, x is equal to 1 over p, which means that p is just equal to t. And that is the same here, 2t, 2p. It works on the x coordinate and it works on the y coordinate. So just check it works in both coordinates. So now I know that p is equal to t, I can replace this t with a p squared. So dy by dx is equal to minus 2p squared. And a lot of people forget to convert this back in terms of p and end up with a value with p's and t's, x's and y's, and then get confused with how to solve to get to this equation here. So if you look at what we're trying to show, it's got a y in it, it's got an x, and it's only in terms of p. So this t needs to be converted into p, which gives me the minus 2p squared. From the question, we know x1 is 1 over p and y1 is 2p. Substituted into the equation of the tangent, y minus y1, so y minus 2p is equal to m, which is minus 2p squared, times by x minus x1, which is 1 over p, and this is your third mark. From here, we now need to just rearrange. So if I expand the right-hand side, I get minus 2p squared times by x, which is minus 2p squared x, and minus 2p squared times by minus 1 over p. 2 minuses become a plus. P squared divided by p is just p, giving me plus 2p. I'm then also going to get rid of this minus 2p from the left-hand side, so I'm going to add it to both sides, which gives me a plus 2p on the end. You can see I've got 2p plus 2p gives me the 4p, which is what we're looking at trying to show. Make sure if it is a show that question, you state that you have shown the answer. So therefore shown, and this will give you your fourth mark. So it's really important that when you get down to this stage here, you show clearly your answer. Don't skip any stages going through here because you think it's obvious. Just state down the obvious to be able to get the full marks in the exam. Now in part B, we've got to show that the ratio p to a to p to b is 1 to 2p squared. And you're probably looking at this question thinking, I really don't know where to start. And that is quite normal at this stage, that you're really not sure where you're going to be able to get this answer here. So as I said up here on our key fact, the key thing here is to be able to draw a diagram. Now in the exam you are allowed a graphical calculator, so if you don't want to sit there and do a table of values in the exam because it's going to take too much time, I would recommend getting a graphical calculator to speed things up, or you just have to sit and work it out. It is personal preference whether you want to have the calculator or not. So I'm just going to show you what the graph looks like. The parametric equations x equals 1 over t or y equals 2t is this blue curve here. The answer we worked out in part A, y equals minus 2p squared x plus 4p, is an equation looking like this. And you can see they meet at a point here, which is going to be my point P. You were told that A is the point where we cross the x-axis. So this curve here crosses the x-axis at point A. P is the coordinate here, 1 over p, 2p, where the curve and the tangent meet. And the point B, okay, is the normal to this curve at the point B. So this equation here is a normal. So it means there's a right angle between this tangent and the line coming across here. So this is the normal. And it crosses the x-axis at point B. So it crosses the x-axis here at point B. Now you've got to show that the ratio between P to A, which is this distance here, to P to B, which is the distance across here, is in the relationship 1 to 2p squared. So basically what you're going to be doing is working out the length of this line, working out the length of this line, and comparing them and showing you get this. Now if you haven't had a chance of doing this yet, press pause and have a go at working out the answer from this stage here. Now you've got the diagram drawn. Okay, the tricky part was actually working out what you had to do. So drawing the diagram helps you see what you've got to do. Now you've got to work out the length here, P to A, work out the length here, P to B, and then you're going to compare them and you will find it cancels down to 1 to 2p squared. So to start with, we're going to look at working out P to A. It doesn't matter which order you do it in, I've just chosen to go P to A first. So we know the equation of this curve here, y is equal to minus 2p squared x plus 4p. And we know at the point here A, we're crossing the y-axis, we're crossing the x-axis, so the y value is going to equal 0. So at point A, the y-axis, we're crossing the x-axis, so y is going to equal 0, which means that 0 is equal to minus 2p squared x plus 4p. We've got to rearrange this to find the x coordinate. So if I add 2p squared x to both sides, and then divide both sides by 2p squared, gives me x is equal to 2 over p for my first mark. So that gives me the coordinate here, a, as 2 over p, 0. So we're now going to work out the length of this line here. So to work out the length of the line, we need to do Pythagoras. So that's the difference in the x values squared plus the difference in the y value squared, the square root of the lot of it. So that is going to be 2p minus 1p, so the difference between the two coordinates here. I've done the a coordinate, take away the p coordinate. It doesn't matter which way round you do it as long as you're consistent. And then you have got the 0, take away the 2p squared, 2p, and that's all going to be squared. Remember, when you square a negative number, it becomes positive. So it doesn't really matter which order you do them in as long as you use the same method for both of them. So 2p take away 1p, or 2 over p take away 1 over p is going to be 1 over p. The 2p all squared, or the negative 2p all squared, is just going to be positive 4p squared. So I've got 1 over p all squared, which is the same as 1 squared over p squared. From here, I'm just going to put these over a common denominator, so it makes it easier to cancel down later on. So both terms are going to go over p squared, which means I need to multiply this second term here by p squared. So the 4p squared times by p squared gives me 4p to the 4. So if I cancel this down, 4p to the 4 divided by p squared leaves me with 4p squared. And the 1 over p squared is the same 1 over p squared. So this can be separated into two fractions over one fraction. Now I can see my denominator has got a p squared, so I can do the square root of the numerator divided by the square root of the denominator. Now the square root of p squared is just going to be p, so pa is 1 over p times by the square root of 1 plus 4p to the power of 4. So from doing this, you've got 2 marks so far. There is quite a lot of marks in order to get down to this stage here, and there is an answer mark later on value once you've got the value of PA and PB both correct. But at this stage here, it's 1 for finding the x coordinate and 1 for trying to work out your PA value using Pythagoras. So now we have got this distance here, P to A. So we know this distance here is P to A, which is 1 over P square root of 1 plus 4P to the 4. We've now got to work out the distance from P to B. Now P to B, okay, first of all we need to know the equation of this line going through P and B, so the equation of the normal. Now you should know that the gradient of the normal is minus 1 over the gradient of the tangent. So my gradient of the normal is going to be minus 1 over minus 2p squared, which is just going to be 1 over 2p squared for a mark. From here, we now need to use the coordinate x1 and y1 again and use the equation of the normal, which is the same as the equation of a straight line or the equation of the tangent. So I'm going to use y minus y1, where y1 was 2p, is equal to m, which is my gradient of the normal, times by x minus x1, where x1 is 1 over p. And this will give you 1 mark. From here, we want to work out the coordinate of b. So at the coordinate of b, my y value is going to be 0. So this term here is going to be 0. I'm going to multiply everything through by 2p squared. So at b, y is equal to 0. Multiplying everything through by 2p squared, I'm going to get minus 2p times by 2p squared. So 2 times 2 is 4. P times p squared is going to be p cubed. So I've got minus 4p cubed is equal to x minus 1 over p. Then adding 1 over p to both sides gives me x is equal to 1 over p minus 4p cubed. And this is another mark. So you can see on this page here, I've got 1, 2, 3, 4 marks quite close together on this stage here. So coming through to this x coordinate here of b, which is going to be 1 over p minus 4p cubed, 0. Now we've got the coordinate of b and we've got the coordinate of p, we can work out the length of p to b. Again, it doesn't matter whether you do the p coordinate, take away the b coordinate, or the b take away the p, as long as you're consistent. I've done the b coordinate, take away the p coordinate. So I've then got 0, take away 2p for the y value. So I've got minus 2p squared again. So I've got 1 over p minus 1 over p. These are going to cancel, leaving me with minus 4p cubed. For minus 2p p all squared becomes a positive p squared. So 4p squared, because 2 squared is 4. I then got to square my minus 4p cubed. So minus 4 squared is 16. P cubed is p to the power of 6. From here, I've got a constant which is going to be able to be taken out the front. So 4 is common to both the letters, or both the numbers, and the letter that's common is p squared. So I can take 4p squared out the front, leaving me with 4p to the 4 plus 1. You'll note this looks very similar to what we had over here when we were working out the distance from p to a. I can separate this into two fractions, two terms. So I've got the square root of 4p squared, which is just going to be 2p, times by the square root of 4p to the 4 plus 1. So I now know the value of pb. Once I've got the value of pb, I know the value of pa, which is here. So we're comparing pa to pb. So we just need to put both of these terms equal to each other, or with the ratio in between. You'll see the bit here under the square root is exactly the same. It doesn't matter whether it's 1 plus 4p to the 4 or 4p to the 4 plus 1, they're exactly the same. So the term here can cancel underneath the roots, leaving me with 1 over p to 2p. If you look at what you're trying to make, you've got to make 1 to 2p squared. So all I've got to do is multiply everything by p, which shows us we've got 1 to 2p squared, which gives you your last mark. So the 7th mark came from working out the two PB and PA correctly, and the last mark came from showing what you've been asked to do. This was a tricky 8 marks in the exam, so it is really important that you know how to do this question. You can use Pythagoras and then you can use ratio, but without drawing a diagram it is really difficult to understand what you're trying to do. So well done if you managed to get it correct. Great work. The mark scheme on part A shows clearly where the method marks, which are M1 and M1 here, 2 method marks. A1 is an answer mark. You cannot get an answer mark without a method mark at A level, so it's really important you show all your working out in order to get the answers. AG just means that it was a show that question, so when the examiner is marking this, if they see y equals minus 2p squared x plus 4p, they know they've got to look really carefully for all this working in able to give you the full marks for the answer. And this was worth 4 marks for part A. Give yourself a big tick if you got it correct. Great work, well done. The mark scheme on this question shows it's a B1 FT. The FT means follow through. So this M dash means working out the gradient. So it's the reciprocal, the negative reciprocal of what you found. So providing you try to do that, you will get the method mark. You can see substituting it in, rearranging gives you another method mark. So you've got lots of method marks. A1 is an answer mark. So you must get to this stage here. Or equivalent to be able to get the answer mark here. Again, this is a method mark depending on your values. So more method marks, and then there are 2 answer marks. Again, you've got the AG, which just tells the examiner that it is a show that question to get down to this answer. And this will give you 8 marks in the exam. If you found this video useful, please share, like and subscribe so we can all get great at maths.